Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer the last questions remaining from Airborne Weather Radar chapter from Keith Williams. So let's begin with question number 61. A height ring is used for what purpose? As a range marker, as a 0 point for range measurement, to determine that the weather radar is functioning, to determine the exact aeroplane height above the surface. So correct option is option delta. Now always remember that your aeroplane transmits a pencil-shaped conical beam. Okay, it transmits a pencil-shaped conical beam to detect weather. To detect weather. A pencil-shaped conical beam to detect weather. Now this conical beam will have some side lobes. Will have some side lobes. Okay, and you can direct this side lobes. You can rotate the scanner antenna of your airborne weather radar, and you can direct this side lobe towards the ground. Towards the ground. Okay, and when they strike the ground and get reflected at the receiver, they produce something called height rings on the display. Okay, height rings. This height rings nothing but indicate height of your aircraft above the ground surface. Above the ground surface. Second thing, when you get height rings on your indicator, this is a good sign, a good positive sign that your system is working. Your system is working, or airborne weather radar is working fine. So you have to remember this too. Next, a side lobe from an aerial of a weather radar may produce an echo on the screen known as height ring. The pilot can use this as a range marker to determine airplane's height above the surface, yes. As a 0 point for range measurement to determine that the weather radar is functioning. So option delta is also right, but mainly height ring is used to determine your aircraft height above the ground surface. 63. The main factors which affect airborne weather radar will detect a cloud are. So there are two factors which determine whether airborne weather radar will detect a large cloud droplet or not. First is the size of water droplet. The second is wavelength of the radar signal. Okay. So when, let's say this is your cloud, and there are large water droplets in this cloud. Okay. So when the size of water droplet is equal to the wavelength of the radar signal, right, is equal to the wavelength of the radar signal, the signal will get reflected. The signal will get reflected. Now, if the size of the water droplets is less than the wavelength of the signal, what will happen? The signal will penetrate the cloud and go beyond it. There won't be any reflection. So next point, very important point. If the size of water droplets is less than wavelength, the signal will pass through the cloud. The signal will pass through the cloud. So the correct answer here is the size of the water droplets and range, wrong. The scanner rotation rate, wavelength and frequency, wrong. The size of water drops and wavelength frequency, yes. The size of water drops and diameter of antenna, wrong. Question 64. The ISO-echo circuit is incorporated in the weather radar to display areas of turbulence, to allow ground mapping, to alert pilots to the presence of cloud, to allow mapping and detection of cloud. So correct answer is areas of turbulence. Now there are two kinds of displays. Okay, there are two kinds of display. In the first one, you have a colored display, and in the second one, you have a monochrome display or black and white display. So in case of colored display, different levels of precipitation will be indicated by different colors. Red stands for heavy returns or heavy reflections. Yellow or amber stands for medium returns. Green will stand for light returns. And black color will stand for no returns. Opposed to this, in a monochrome display or black and white display, area of heavy turbulence will be indicated by white color. Now, white color will be shown how? There will be a black ring, and this black ring is nothing but your cloud, and the white shade, the white color inside it, is nothing but where you find turbulence in the cloud. Okay, so this is how monochrome display is used. So the correct answer is iso-echo circuit, monochrome or black and white, is used to display areas of turbulence in the cloud. 65. When the airborne weather radar is operating in its primary mode to detect precipitation. Now, airborne weather radar is used for two purposes. The first one is the primary function, which is detecting weather. The second one is ground mapping. So the second one is mapping. So mapping or navigation. So when it is operating in weather mode, the radar beam is a cosecant beam, wrong. The radar beam is pencil beam, yes. Maximum tilt will be used, not necessary. The range will be limited compared to the range obtained in ground mapping mode, wrong. So when you use the airborne weather radar in weather mode, the beam is conical or pencil shape, conical or pencil beam. A fan shape or cosecant beam is wide. Therefore, it covers an area which is larger than one covered by pencil beam. Okay. As a result, you may get reflections from water droplets, as well as land surface or ground surface. If this happens, it will be difficult to differentiate between a ground return and weather return. A ground return and weather return. Okay, so that's why we use pencil shape or conical beam which is thin in size, and therefore there won't be any possibility of getting too many ground returns like in fan shaped beam or cosecant beam. So the correct option here will be option Bravo. 66. Airborne weather radars use a frequency of 9 GHz, which is a super high frequency, because the frequency penetrates clouds, goes through them, easily enabling ground mapping of ground features. Short wavelength allows signals to be reflected from cloud water droplets of all sizes. The wavelength is such that reflections are obtained only from the large water. It has a short wavelength, so producing high frequency return. The correct option is option Charlie. We use 9 GHz frequency because the wavelength it has is around 3 centimeter, 3.2 centimeter. And with this 3 centimeter wavelength, we can generate returns or get reflections from large size water droplets. Small size water droplets are not a concern, are not a cause of concern or irrelevant to us because small water droplets are not indicative of any kind of turbulent cloud. Whereas large water droplets will be only found in clouds uh, that are uh, that are relevant to us, relevant to aviation safety, like cumulus cloud, cumulonimbus clouds, like that. So it is important that we get reflections from large water droplets and not small droplets, and therefore we use 3 centimeter wavelength. When using airborne weather radar to detect long-range ground features, the most suitable mode of operation of beam would be manual mode, mapping mode, contour mode, fan shape mode. So the correct option here will be, if you want to detect long range ground features, so it is better to use manual mode. In the manual mode, you can get conical beam or pencil shape beam. Mapping mode and fan shape beam uh, both use cosecant or fan shaped beam. Now, I have repeatedly said this, that for the 70 nautical miles, we make use of fan shaped beam, and for the next 70 nautical miles from 70 to 150, we make use of conical or pencil shaped beam. Okay, so for long ranges, it is very important that we use conical beam or pencil beam. That's why that is possible in manual mode. Using the airborne weather radar before takeoff, the gain control should be adjusted according to the flight conditions expected after takeoff. The contrast control should be adjusted to maximum control or maximum contrast. The radar transmitter should not be operated when personnel are observed in the sector ahead of aircraft. The antenna tilt should be set to maximum negative tilt. So just before takeoff, okay, so just before takeoff, you will have to adjust the gain control knob according to the flight conditions expected after takeoff in your flying path. Now, what is this gain control knob? Okay, gain control knob. This gain control knob, I'm writing it here, adjusts the transmitter power. Okay, so objects or targets at close ranges will generate heavy returns compared to objects or targets at far away distances, at far away distance, right? At far away distance. So that means the picture that you see on your airborne weather radar screen, airborne weather radar display, will be quite lopsided. That means the objects which are close to your aircraft will be displayed on your radar screen as very bright returns, but whereas reflections coming from targets far away from your aircraft will be displayed as very light returns. Okay, very light returns. So close to aircraft, very bright, but far away from aircraft, let's say very light returns like this. I'm showing it with yellow color. So in order to establish a balance between all the returns, whether they are coming from close ranges or far away ranges, we adjust the gain control knob of your receiver. With that, the transmitted power, okay, the power of the transmitter will be less. The transmitter power will be less at short ranges. The transmitter power will be more at long ranges. At long ranges. Okay. So this is how you get a equal display, equal display of returns from close targets as well as far away targets. So option A is the right option. Next, if airborne weather radar transmitter is to be switched on before takeoff, the scanner should be tilted up with weather mode selected, mapping mode selected, either of the modes selected, none of the above. So just before takeoff, it is very important for the pilot to know the kind of weather he's going to expect in his takeoff path, in his climb path. Okay, so if this is your aircraft on the ground, just before takeoff roll, the pilot will operate his airborne weather radar in weather mode in order to check whether there is any kind of weather to be expected in its takeoff path or climb path. Okay, so there may be some clouds, some dangerous clouds in its takeoff paths like that. So it is very important for him to make or to have an idea of the kind of weather that is going to be expected in his flight path. So the correct option here will be weather mode is selected. Mapping mode is not right answer. Mapping mode is nothing but navigation mode. So just when you are on the ground beginning your takeoff roll, what is relevant to you is weather mode. Mapping mode can be used during cruise phase, navigation phase. Airborne weather radar in dash mode progressively brightness as distances to equalize screen. So airborne weather radar in the weather mode, so the meaning of this question is that what I have explained just here, gain control knob. Okay, so to obtain equal to obtain equal display of all the returns, whether they are coming from close ranges or far away distances, you use the airborne weather radar in the weather mode. Okay, in the weather mode. After using it in the weather mode, the gain control knob control knob to decrease power, to decrease transmitter power, as range decreases. As range decreases. Remember this. 71. Airborne weather radar uses the following wavelength. That wavelength is centimetric because airborne weather radar functions in the or uses the frequency band super high frequency, and all wavelengths corresponding to that frequency will be in terms of centimeters. Okay, so centimetric is the answer. Before commencing a flight, the weather radar should be kept at standby until line up with the runway, not be switched on until clear of buildings, be switched to standby but not used until airborne, be switched to a range function after pushback to make sure it is functioning. So the correct option here will be before commencing a flight, the weather radar should be kept at standby until you are lined up with the runway. Once you are lined up with the runway, you can switch it on in order to determine or detect if there is any weather in your takeoff path, line path. 73. The use of airborne weather radar on the ground is not permitted. Is permitted provided reduced power is used. Permitted provide special precautions to safeguard personnel and equipment. Yes. So airborne weather radar is harmful for the health of any personnel around aircraft. It can ignite fuel vapors and also it can damage airborne weather radar itself. That's why it is permitted only if you follow special precautions, guidelines, recommendations of manufacturer. So 73 is C. In an airborne weather radar with a colored cathode ray tube, areas of greatest turbulence are indicated by most rapid change of color, where the color zones change most rapidly. Red, yellow, green, yellow, red, like that. Okay, so let's say this is your weather radar screen. So areas where the colors change very quickly over a short distance, okay, over a short distance, is where you will expect heavy turbulence. Is where you will expect heavy turbulence. Okay, so as you transition from green zone to yellow zone to red zone, you will experience bumps turbulence. Airborne weather radar contour mode is used for what? Identifying areas of maximum turbulence within a cloud, identifying rain bearing clouds, short range mapping, long range mapping. So contour mode is nothing but your weather mode. So it is indicate areas of maximum turbulence within a cloud. This concludes our lecture, and with this question I have also answered all the 75 questions from Airborne Weather Radar chapter in Keith Williams' book. I have also answered and solved all questions from Oxford book, Ground Studies for Pilots by R.B. Underdown book as well. So do watch those lectures also. I wish you all the best, and if you have any doubts, comments, feedback, questions, let me know in the comment box. I will answer them. And I request you all to subscribe to this channel if you haven't yet. Share this video with your friends who are preparing for exams, and hit the like button if you have liked this video lecture. Thank you for your time. Don't miss my next lectures on secondary surveillance radar and transponders. See you there.